just wanted to walk those of you through. I'm sorry, I had that pop up ad. I wanted to walk those of you through who haven't actually done some forecasting in Excel before using this 3-period moving average, what that should look like. So if I were going to put this into Excel, I would highlight this and use the code. Don't use that menu. Highlight this. And so I have to be kind of careful. So I want to just grab this and I want to use Control C. And when I use Control C, I can come over to Excel. And I've already done this, but I'm going to do it again here so you can see it. And I can go Control V and it will copy it in appropriately. Now I did that, but then I revised the numbers because I don't want you to just be able to look at this and see the answers. But let's read this question again. So it says, Beyond Tea Incorporated wants to forecast sales of its menthol green tea. The company is considering either using a simple mean or a 3-period moving average to forecast monthly rates. Given sales data for the past 10 months, use both forecasting methods to forecast periods 7 to 10, and then evaluate each. Which method should they use? The selected method to make a forecast for month 11. Okay, so we're going to pretend like we have this data, but I've revised it so that you won't just be able to copy and paste answers in. And we're going to come back over to this spreadsheet and we're going to walk through how to do that. So first I wanted to come back and just gather so I did a quick search on simple mean to come back to your text so that we can take a look at what do they mean when they say simple mean. So what they're saying is basically you just take an average of all of the data that you have, right? And then with a moving average, what you do is then you say, okay, I'm only going to go back for X number of periods and take the average of those time periods. So if we go back to this problem, which was, I believe, on page 189, right? It's saying that use a simple mean or a 3-period moving average to predict times periods given sales data for the past 10 months to predict time periods 7 to 10. Okay, so I had gotten the information into Excel, right? And so I'm again going to use something different here, but we are wanting to forecast these time periods, right? And so the first one says, let's do a simple mean where we're going to average all of the data that we have. So if I'm going to do that, I'm going to go and I'm going to use my average function here. And I'm going to grab from this first one time period all the way up to the most recent one. But because we're going to always gather all of the data that we have and take the average of that, right? I want to fix that first cell reference by putting the dollar signs in there so that when I copy the formula down, it automatically adjusts, okay? And just to make this look a little bit nicer, I'm going to format my cells. So I'm going to right click, format cells to 2 decimal places. Okay, so this is the simple mean. And we need to evaluate between these 2 measures that we're going to do, these 2 forecasting methods, which measure actually works the best. So I need to understand what my forecast error is, and then I need to calculate my absolute error. And from that, we'll be able to get a measure of forecast of how well this method forecasts in comparison to the next method that we're going to do. So my error is always actual minus forecast. Alt return so that I could get that to show. Okay, so actual is what we have here, and forecast is what we have here. So boom. There are my errors, and then I need the absolute value of those errors. I'm just going to do ABS, boom. And again, we're going to format these cells to be 2 decimal places. And then I want to take, to get MAD, MAD is the mean absolute deviation. And so what I'm going to do is I'm going to average the values of my absolute errors. That tells me that using this forecasting method, the simple mean, right, my MAD is 6.43. I'm going to go ahead and copy this over, because why reinvent the wheel when all I need to do is revise this to be simple moving average for 3 time periods, right? And so instead of averaging all time periods, and I should have just checked this while we were here to make sure that each one is getting all of the relevant data. So what I want to do here is I want to say, I want to average, right, the 3 previous time periods. Boom. And I want that to be relative. So I'm not going to fix any cell references, and I'm going to just copy that down. And we can see that there's not a real significant difference in the data that I have, because the absolute error here is 6.43 and the absolute error here is 6.33. Let me show you what we mean by that error. Boom. So here's, let's say these are our data points. I'm going to draw kind of right over the top of this, right? And what we're trying to do is forecast the next several time periods. Okay. And so when we forecast, right, so these are actuals, and then let's say these were our forecasts. And our error is going to be the difference between our actual and our forecast, right? That's what we're getting in this column. So over time, what I'm going to see is, let's do a linear regression prediction, right? So if this is my forecast and these are my actuals, it's going to be a little bit easier to see this way. If I just use error to address how accurate I am, I'm going to have positives and negatives. And when I sum those up at the end of time, that's what we call our running sum of forecast error. And that tells us over that period of time, as we're adding our pluses and minuses, how much did we miss our forecast overall? But what's relevant also is each time period, what is the average distance between my forecast and my actuals, right? Because, for example, I could have, I could be 100 above and 100 below and 100 above and 100 below. So my forecasting technique might not be that great, but over time, those are going to end up being 0, predicting, showing that I'm actually predicting across time fairly well, but by time period, it is not going well. So that's why we use MAD, because we want to understand the average, the absolute value of these, the average differences between our forecast and what we're using. Okay, so that's how I would approach addressing simple mean and simple moving average. And I would look at the value of MAD, right? I'll go ahead and type in, I need to get off of this and be back to this. And so I would, you know, this is my MAD for this method, and this is MAD for this method. Okay, so that's that first problem. Let me go ahead and get set up for the second one. So to show you how to do the apple cakes problem, which is actually on page 218, I think there was an initial typo in the problems. I think it said 128, but it's actually on page 218. It's going to be the computation of lead time for a fixed time period system. And so what I'm going to do is we're going to go over this example, and I'll do it so that we can show similarly how this would be done with the apple cakes problem. So we're given the information that we review the inventory every 14 days. So when we review that inventory, that time, capital T, is 14 days, with demand and lead time given below. So demand is 30 units per day. And I'll let you know, in the problems that I see, this D is actually small d, because when we're talking about less than a year, we use small d, and you'll notice that's what's actually in these equations. Capital D typically stands for an annual demand, okay? And then L is the lead time that we have. So from the time that we order till it's going to arrive is 7 days. And then we have a standard deviation per day. Okay, so we're given a formula that says, and this should make sense to us, that we're going to order the number of units based on the average demand times the lead time, because we won't have any units in house for that, plus that average demand times the number of review days before we're going to review our order again. Okay, so that means that it's going to be small d times L plus small d times T plus safety stock. Now, safety stock is the one that's maybe a little bit trickier. So I'm going to go ahead and open up a new Excel file. And I'll just bring this over to half the page here. Okay. And so what I want to do is I want to say that I'm just going to, so our T in this case is 14, and I'm going to put days because it's important that we're using the same unit of measure. Small d is 30 units per day. L is 7 days, and our standard deviation is 10 units per day. Okay, so the first part of this equation where we say R is equal to small d times L plus small d times small d times T plus safety stock, right? We do this term by term. D times L is going to be this demand of 30 units per day times this lead time. And D times T is that demand again per day times the review time, the time in between the reviews. Okay, so we're good there, but then we have to get to our safety stock. And our safety stock, I've kind of worked this out on another where I can just copy and paste it over so you don't have to watch me type this out. But here's what our safety stock is equal to. It's equal to the Z-score for our service level. So what is it that we're trying to achieve? What's the on-time delivery service we want to achieve? And then we need to get a Z-score for that. If Z-scores don't come back to you naturally, there's a whole bunch of YouTube, Google on normal distribution and Z-scores, and take 3 to 5 minutes to watch one of those, and you'll understand that the Z-score gives us the percentage that we have to meet in order to be able to meet this criteria that we're looking at. So under the normal distribution curve, a Z-score tells us how many standard deviations away we need to be from the mean in order to meet this service level. Okay, so we take that Z-score and we take it and we multiply it by the standard deviation of demand, and we multiply that. So we have the standard deviation per day, and then we need to multiply that by this term to get to the standard deviation during lead time. And that term is the square root of L, our lead time, plus T, right? The number of days between the review periods, and small t. And small t stands for, I believe it's the unit of measure for our standard deviation. Yeah, the interval over which standard deviation is given. So it's a standard deviation is given during 1 day in our case. So it's going to be, that's going to be 1. So let's do this. All right. So in this problem, boom, to get to what's our service level is our first question. And what we're saying is that we want no more than 2 stock outs. Okay. So what percentage is that for us? Well, we know that we order every 2 weeks. And there are 52 weeks in a year. So that means that we're going to order 52 divided by 2, 26 times per year. If we're going to allow ourselves 2 stock outs, sorry, that should be equals 2 divided by 26. That says that we're going to be, that's our stock out percentage, that 2 divided by 26. So to get to my service level, I need to take 100% minus the stock out level. Okay. And again, I just want that to be 2 decimal places. So I'm going to decrease that down to 2 decimal places. So that means that my stock out, my service level then is 92.31%. Okay. So again, I need to know what my z-score is to use in this formula. So this is all what we're doing here is just to get to this z-score. Okay. So my z-score, Excel is wonderful. It tells us the z-score by just using the norms inventory function, NORMS-INV open parenthesis, and highlight that service level. And it's going to return to us the z-score for a 92.31% service level. Okay, so all of that was just to get the z-score. All right, so I'm going to go, my safety stock is going to be then equal to the z-score, which we're going to go ahead and round off 1.426 times the standard deviation, right, times the square root, open parenthesis, open parenthesis. I need to put my lead time and my time between reviews together in the numerator, close that and divide it by, and our unit of measure is a day. So that's only going to be 1 day. And if life is good, boom, that gives us 65.34. And so when I then sum these up to get to the amount that I should order in order to achieve this 92.31% service level, we're saying it should be 695.35. Let's see how we did here. Yeah, so that's going to be close enough. That's going to be close enough. Yeah, so again, we probably had maybe a little bit of a rounding error in there. Maybe they went out more decimal places than what they're showing, but we're right on the 630. We're right on the 1.426. We're right on the 10. So we might have a little bit of a rounding issue in this square root that we're taking, but again, close enough for where we're going to be at. So that walks you through how to do those 2 problems. I hope you find that helpful. I look forward to looking at your Excel files when you submit them. That's what I prefer that you submit, because then I can look and see if you didn't get it right, where your math went wrong. But if you submit it in a Word document, you'll just need to show your work as well. All right, that should do it.